This video is all about a basic introduction to linear relationships. So whenever we have an equation, it is often much easier to understand what is actually going on if we graph it just to get a picture of what that relationship is. And to do that, we use what we call a Cartesian plane. And this we often know is just an x-y axis, and I've kind of drawn one down here. We have the x is the horizontal axis and y is the vertical axis. Now just a couple of things about the Cartesian plane, named after a guy named Rene Descartes, all right, famous mathematician. We have here the four quadrants, and so I've just listed them there, and it's important that you understand these because we often talk about where a graph exists in terms of these quadrants. So we've got the first, second, third, and fourth quadrant moving around the Cartesian plane, the first being the positive for both x and y. When we've got our Cartesian plane, we can then graph the relationship as a series of coordinates or points. So we understand that we get a coordinate, we're going to have an x and a y value. We always move across on the horizontal for our x coordinate. So for example, if I had the coordinate 1, 2, I would go across 1 on the x-axis to 1, and I would go up 2, all right, to about here, and that would be my coordinate 1, 2. And so when we have an equation, we just group in a series of coordinates and we're connecting those lines. So for example, if I found another coordinate that lay on that graph, might be 3, 0. So I'm going to go across here. We'll say that is 3, 0. Okay, that's going to run on. And you can quite clearly see if I joined those and said this is a linear function, and we're going to have a nice straight line through these, and that would be my graph, and that's what's going on. Linear relationships are always straight lines, and that's really important because as soon as I see an equation, I get an idea in my head of what it's going to look like. And if we have a linear relationship, it's going to be a straight line. How do we know whether something is a linear equation? Well, we say they have an order of 1, all right, and that's really important. All the pronumerals, so all the letters, have a power of 1. So there's no squares or cubes, there's no square roots, anything funky like that. And you can see I've got a couple of examples here. Y equals 2x minus 7, 3y minus x plus 44 equals 0. Okay, we can have fractions in there as long as our pronumerals aren't in the denominator. So these are, as soon as I see an equation like that, I'm going straight away, oh, that looks like a straight line. All right, so a couple of other things about them. I'm going to talk about some intercepts. So we have what we call an x and a y intercept. Now the y-intercept is basically where the graph meets the y-axis. So if I looked at a little graph I've got here, my y-intercept is this one down here in the pink at -4. You can see where my line is hitting that axis. All right, so right here my y-intercept would be at -4. And the x-intercept is where the graph meets the x-axis. So in this circumstance, you can see I've got an x-intercept of 2. Now, an easy way to find those is because of the y-intercept lies actually on that y-axis, all the values of x along that line are going to be 0. So I simply substitute in when x equals 0 into my equation, and that will find me the y-intercept. Likewise, to find my x-intercept, my y value now equals 0. And so I substitute y equals 0 into this equation. We can see if I've got this, if I wanted to know for my y-intercept, I could say let x equals 0. So therefore, y equals 2 times 0 minus 4. Obviously, 2 times 0 is 0, and so we're just left with -4. Happy days. There's my y-intercept at -4. All right. A really basic method of graphing an equation is actually just to find a series of points or coordinates. And to do this, we simply substitute in a value for one variable into the equation to find another. Let's have a look at an example of what I mean there. So if I consider the equation y equals 3x minus 1, I might draw up a table of values. I'm sure some of you are pretty familiar with this. So I've got my equation, y equals 3x minus 1, and I'm essentially substituting in for this x value right here. So I'm going to put in some of these, and often I'm going to start with basic values, integers, some negative, a 0, and some positive. So let's start with 0 because it's a really easy one. So y equals 3 times 0 minus 1, which is obviously -1. So happy days. That's my coordinate, 0, -1. So these here become my coordinates. Let's have a look when x equals 1 now. So y equals 3 times 1 minus 1, which just equals 2. Happy days. And then I can go y equals 3 times 2 minus 1. 6 minus 1 is 5. All right, and you can go through and do that for all those values. I'm just going to fill them in because I can do this. Minus 4 and minus 7. And what you might notice with a linear function is that there is a nice little pattern here, and we'll talk about that later. It's actually called gradient. Now, this whole idea of being able to find tables of values or substitute some points, do not think that this is an awkward technique. It's something that even at the highest levels of maths, people still use this just to get an idea of what can be going on. Okay, so it's still a really, really important and useful technique. Obviously, we're going to learn faster techniques to graph later, but this is an important technique to learn and understand because it doesn't fail. All right, obviously there's going to be a faster ways to do things, but this is a really important one to know. So learn this technique. As it's a nice security blanket. And what I mean by that is it's a nice little safeguard if you're stuck. A nice security blanket if you're stuck. All right. So once again, now that I've got this table of values, if I wanted to graph that y equals 3x minus 1, I can simply now construct for myself a Cartesian plane. So let's have a look here. Now, just drawing pretty rough here. Obviously, it's a good idea to use rulers when you're doing these, but I can just plot these points. So let's go through. I always started the y-intercept being minus 1 here. That's nice. When x equals 1, y is equal to 2. So we're going up quite steep here. All right. So that's my point 1, 2. All right, and then 2, 5. So I go across 1. I'm going up pretty much the same thing. So there's 2, 5. And if I continue, I can plot all of these points when it's minus 1 or down at minus 4. And what you'll notice here is, sure enough, they're creating for me a nice straight line. Sorry, here. Not the world's best straight line that I've drawn. But you're getting a nice straight line here, and that is my linear function. And all of those points, as we've done from this table of values, are going to fit down in there. Whenever we're graphing something, always important to write our equation on there. So we'll finish off by writing that. Y equals 3x minus 1. And there is my graph. That's it, guys. That's an introduction to linear functions.